Hi everybody, I'm making a video for you today on magnets, okay? So a magnet, as we've experienced, is a material that creates or generates a magnetic field around it. This is an area of force that surrounds the magnet. The magnets are only attracted to materials that are made of nickel, iron or cobalt. Steel is attracted to magnets because it is mostly made up of iron. Most other materials like wood, plastic, glass, aluminium, silver and copper are not attracted to magnets and they are called non-magnetic materials. The reason why the aluminium, the copper and the zinc that we tested were not attracted was even though these materials are metals, they are not metals that are made up of iron, nickel or cobalt, whereas the stainless steel knife that we tested is made up of iron, so it was attracted to the magnet. Larger magnets are generally stronger than the smaller magnets, as long as they're the same type of magnet and they're the same shape. Magnets do come in different shapes, like bar magnets or horseshoe magnets or round magnets, square magnets even, and the shape of the magnet, each different shaped magnet, I should say, has a different magnetic field that surrounds the magnet. Okay, there are a different type of magnet that are much more powerful than our normal everyday common magnets that we use in school and at home, and these are called rare earth magnets. You might actually have seen them in shops like the National Geographic. Sometimes they have them in there and they use them in games and other kind of things, and they are very strong and they're made of alloys of rare earth elements. I've actually got some, so I'll bring some in to school and show you. Actually, I've just gone into the fridge, and not into the fridge, into the kitchen, and I've pulled out this. This is just an ordinary everyday magnet. So it does attract the spoon. It's not very strong though. I mean, if I stick it on the side it will attach, but if I try and stick it on the bottom it doesn't really have enough strength to hold the spoon, because the spoon is too heavy for the magnetic field, or the force that it's, the magnetic force. Okay, but this is a rare earth magnet and it easily has enough strength to hold on to the spoon. So very cool, really strong magnets. Now, something else I thought I would show you. Oh, where is it? Now, we were looking at how magnets can attract things from a distance. Okay, so here's my rare earth magnet. Here is my bobby pin from my hair. Can you see that? There we go. So I'm going to hold this here. At the moment I can't feel that it's pulling, but when I get close enough I can actually feel that magnet pulling it. So if I let go, it should just jump up. Okay, I can feel the pull and it jumped up there all by itself. So I didn't put it there. It just jumped up. Now let's see if it can do that on the other magnet. So here's my common everyday fridge magnet. I can feel the pull. Oh. Try again. See if I feel the pull. Oh. See, I got really close. I could feel the pull, but it wasn't strong enough. There we go. I had to get really close for that to work, didn't I? So you can see that our rare earth magnets much stronger. I really like the spoon demo. That spoon's not coming off. That is some strong magnet. A magnet produces a field that attracts or repels other magnets or objects. If the magnetic field is strong enough, the object will move towards each other. The magnet attracts the fridge because, so imagine this is a fridge, so that's the fridge. But because the fridge is so heavy, the magnet moves towards it. Okay, like in our investigation. Remember our investigation, we had a tin of tomatoes? The magnet moved towards the tin rather than the tin moving towards the magnet. That's just because the tin was so heavy that it couldn't move, okay? But although the tomato can doesn't move, you can feel the pull of the magnet when it gets close enough. So I can feel that pull, okay? That's the same as our fridge. Here's our fridge, okay? Fridge is attracted to the magnet, but the fridge can't move because it's far too heavy. So the magnet moves towards the fridge instead. Okay, I can feel the pull when it gets close enough, and the magnet moves towards the fridge. Magnets play a vital role in many everyday objects. Vacuum cleaners have powerful magnets in their motors, and this is what gives them their strong suction. Telephones have magnets in their microphones and in their speakers. Without magnets, there would be no telecommunication. Smartphones have magnets and a coil inside, and that's what gives them their vibrating function. Cupboard doors have magnets on their door latches. So when they close, the magnets are attracted to that. There's the magnets, there's the little bit of steel, and it closes up and keeps them together. Microwaves have two big magnets in their magnetron, which is in its motor in there, and that's what's used to heat the food. Electric can openers have a magnet that holds the lid on while the can opener opens the can. And the last picture is a massive, I'm going to make this picture really big because it's pretty cool. Recycling plants use huge, strong magnets to help them sort out the scrap metal. See, I bet you didn't realise that magnets were so important and so interesting. So that's the end of this video. I think it was a bit long, but remember to summarise the key important facts and to ask a question if you've got one. See you next time.